All right, so we're going to go through the module 5 assignments here, starting here with problem 10.1. So what this problem is getting at, and of course pause it to read over it as we go through this, but this is the difference between what we call the clean price and the dirty price. Because we like to keep the invoice price as simple as possible, right? And so we're just calculate that as normal. But then we know that when you go to buy this, you have to pay for the accrued interest since the last coupon payment, right? So we calculate what it will be, and then we have to calculate what that extra little bit of interest is. In this case, it ends up being just under $5, and we have to add that back in to show that price. This problem is similar, only this gives us the last one was a 30-day month. This one right here is 15 days, and we're looking at a 182-day coupon period. But again, all we're doing is calculating that little bit of residual interest. Again, this is when you hear dirty price and clean price, this is what we're talking about, that we have to add in what the interest payment is. All right, and so we have this is using the BA2 Plus financial calculator, right? And so when you use the financial calculator, the PV, FV, N, IY, PMT, that time value of money row, right? We'll just use that to solve for this. And here's how you would put it in. Remember, the future value is going to be the par value, what this face value is, right? N is the number of periods. In this case, it's 4 years, right? 0 coupon, so 0 payment. Here's problem 4. So for current yield, you use the current price. That's the easiest way really to think about it. So it's the yield, like coupon, that you would get, but instead of dividing it by par, which is the coupon rate, you divide it by the current price. Now, of course, if the current price is equal to par, it's going to be equal to the coupon rate, but we know that holds anyway. Okay, and then problem 5 here. Again, we have an semi-annual payment, and we're trying to say what would the coupon be if it were being paid annually, right? And so this is the difference between a semi-annual compounded versus just an annual rate, right? And so it has to be a little bit higher for that compounding. Okay. This is one that gets into a little bit about the relationship with par and yields, right? So if it is selling at par, the yield to maturity for the bond is going to be equal to the coupon rate, right? It's when that diverges from par that you see the yield to maturity and coupon different, right? And if you're going to be holding a bond, all else being equal, if you expect the bond, the rates are going to fall, right? If you're holding a bond that's already low, so if the yield were to fall, the capital gain is going to be limited, so that's really what we're looking at. Okay, and again, for this one, we would also use that financial calculator, right? Where, we have the N, IY, PV, PMT, FV, right? That time value of money row that we've used in our previous classes. We're going to do the same thing, place those in to solve what our the yield to maturity is, but then holding that yield to maturity constant, calculating what the new price would need to be after 1 year, right? And we'll go from 10 to 9, right? And so we can see what the new price is, and then that difference in price from 850 to 850, 895 is the capital gain, right? The rest of it was off of the coupon payments. Okay, here's problem 10.8, the 8th problem in chapter 10. Right. And so we have a 20-year zero coupon bond. Right. We have a yield to maturity, and then the face value is $1,000. That's the par. Right. And then they're asking us what is the imputed interest rate. So I have down here how we would calculate that. So you see like 1, 2, and then 19, 20. So for first, second, and then the last year is what we're doing. Again, pause that as needed. Okay, and this is one of these questions where they're really trying to get you to understand sort of the relationship, you know, between where the call would occur and then what would be the higher yield. All right, and on this one, I went ahead and I just put the way we enter it because again, this is just using the calculator. You know, there's no reason to do this type of calculation, you know, by hand, especially since we have calculators that they're specially made for that. So just keep in mind these are semi-annual, which is normally how bonds will sell. So you just need to make sure you adjust your interest rate and your number of periods appropriately. Okay. This next one, again, it's using the financial calculator. But yeah, so you have the information as presented here. They give us a coupon. They tell us what the current price is. We assume that the par value is 1,000 unless told otherwise. Let's see. Right, and then it's annual, so the 9 years is just going to, you're just going to use that as 9. So, but yeah, so that's the stated yield to maturity than our actual yield to maturity. Okay, and so in this one here, problem 12, what we are looking at, right? So this is 3 different years, right, going forward, right? And so you're seeing that the inflation rate is 1%, so the par value is increasing because these are inflation protected, right? This is the tips. So we raise the par value based on what inflation is, right? And then you see how this coupon payment is also changing, right? Okay. And so this is how we calculate the real return as well as the nominal return. Okay. Okay. So this one we're looking at a yield curve, right? We have a 1 year, a 2 year, and a 3 year maturity. These are all zero coupon bonds, so there's no interest payments between, right? So we know what the yield to maturity is, right? And so they're asking what are the forward rates. So the forward rate is I could buy this 2 year maturity and get 10.5, or I could buy a 1 year, only get 9.5, and then reinvest it after the year for another year. And then 9.5 and this other return is the same as getting 10.5 for 2 years. Hopefully that makes sense. I'm implying that interest rates are going to be much higher in the future based on what these interest rates are, because if this is a better deal, I will always buy these, forcing these interest rates down and the other rates up, right? So we have to have these converge, right? Let's see. And this is just a question, making sure you understand about this expectation, right? Because we normally what the term structure looks like is based on what our expectations of the future are. Okay. We're going to calculate this yield to maturity. Okay, and then of course, yeah, the 9.5. Okay, so and then here's the way we work through those, right? And so to calculate these forward rates, right, we just have to figure out how are we going to, not 1 plus 9.5 plus times 1 plus 11.51% would be equal to the 1 plus 10.5% squared, right? And that's how we have to solve for those. We go ahead and calculate those prices because we need it for C here to get those returns. And then you see, in D and E how we calculate those bond returns, although we would expect it again to be the 9.5. Okay. And then this is the 10.4. This is the 14. This is the last one in chapter 10. So they give us a yield to maturity for a 1 year and a yield to maturity for a 2 year, right? And so 1 plus 7.9 times 1 plus whatever this is would be 1 plus 8.9 squared, right? Because this is 2 years. So I get 8.9 and then 8.9. So you see down here where we solve for that to get the 991. If you believe it, what's your best guess for short-term interest rates? Well, we would expect it to converge on that. That's the expectation, right? So that's the expectations hypothesis. And then if you believe in liquidity preference theory, would it be lower or higher? So you're going to have value just in the fact that in a year you have cash, right? Sometimes people just like to know that that's there. That's that liquidity preference. And so people will prefer shorter term just for that, right? There'll be more opportunities perhaps in a year. So that's what that drives. Okay, so moving on to chapter 11. Right, so this is duration, or actually modified duration, right? So they tell us what the current price is, and they tell us what the yield to maturity is, and that the yield is going to increase this much, and that the price of the bond is going to fall to that price, so we can calculate the change in the price of the bond, right? And so what's the modified duration, right? And so it's the modified duration times the change in the yield to maturity times the price is equal to the change in price, right? So we know we have our change in price, and then we have the yield change, and then we have our initial price, right? And so we can calculate what the modified duration is. Okay. And then this right here is we have a change here in our yield, right? 75 basis points. Based on that duration of 7.2 years, how much does the bond price change, right? So it's the change in the price over price is equal to the negative duration times the change in yield over 1 plus the yield. All right, so once you plug that in, you get that 4.87% decline, right? And because we're multiplying it by negative duration, hopefully it makes sense. Positive increases in interest or negatively increases or decreases, I should say, in price. Here's problem 3. You see it's broken into 4 parts, A, B, C, and D. So feel free to pause this, or you can jump back and look at this particular problem. I'm going to show you the setup for the solution. Okay, and then just understand, for calculating this is the time until we're going to get those payments multiplied by the payments. Then we're going to calculate the present value of those, right? And that's going to determine how much weight, right? So this divided by that, this divided by that, that's those 2 weights, right? And then we take what the payment is times the amount of weight, right? And then that gives us, what that sum is, right? We're trying to immunize this, so we want to get, we want to match, obviously, that duration, right? And then if you notice down here, there is a slight difference, right? That 23 cents, if it's perfectly immunized, shouldn't it be 0? And it's like, well, there's a little bit different. And it's because the duration changes slightly as it starts to change, right? So, but if you notice it doesn't change that much, right? The 23 cents. Okay, and again, feel free to pause this and go back and forth to look at those. Okay. Same thing here. Feel free to pause this and take whatever notes you need. I'm going to have the setup on the next slide, but it's going to be a little bit. So to understand, um, we have this 5-year, 20-year, right, that we're looking at. So we have a 5-year zero coupon and a 20-year zero coupon that we're going to invest in to be able to immunize this position for these lifetime annuities. Right. And again, let's understand that this weight, obviously, the weight times the 5-year, and then 1 minus the weight would be times the 20-year, because again, all of our money is going to be in 5 or 20-year zero coupon bonds. Okay, so this is convexity. So this is the second order, right? So we calculated duration before. Convexity is going to be this measure where we're going to have the squared term, right? Like I said, it's like a second order type of problem. So this is the same as t times 1 plus t. So we say this t plus t squared to get how we're going to weight the present values, right? So it's a little bit different than the way we calculated duration, which we multiplied times the time period. This one it's time plus time squared, right? And that's how we weight that to get our convexity. Okay, and this is looking at the difference between zero coupon and coupon bonds, right? And how they change when there's changes in interest rates. So first, just go ahead and take notes, or you can go back and forth, obviously. In the next slide, I'm going to show you the setup. Okay, so again, we're going to use the financial calculator for these, but we're going to calculate what happens with our zero coupon bond and with our coupon bond, right? And then you see what the difference is, based on those losses, and then what we would have with the duration convexity rule, right? Where it's just negative duration times that change, and then 1/2 of the convexity times that change squared. And then you see again here, the actual gain and predicted gain, we're going to calculate again using the same duration convexity rule. And it's just to show that it does a good approximation of what it will be, although it does a better approximation the smaller the change. Okay, here's a pension plan that we are looking, we're required to make these types of disbursements. And so what we want to do is go and allocate a portfolio to match this. This is a lot of what we end up doing when you're managing these types of accounts, is trying to manage the balance of payments. But again, here's weighting all of that based on what these payment amounts are as a percentage times this duration, right? Or the time times that weight. So okay, again, here's problem 8. I show you how we calculate splitting it between a zero coupon bond and some sort of perpetuity. And here we are, we're given these various yields, right? And so what do we expect these to converge to, and based on what the yield to maturity was, and then what we expect it to go to. Okay, now this one, again, I'm going to show you all the information here, and then on the next slide, I'm going to set it up. So we have the expected rate of return for a 20-year bond over a 5-year period, and then a 10-year bond over the 5-year period. right? So we're looking at two different bonds, one's 20 and one's 10, and I'm calculating what the expected rate of return is, which we already know how we can put this in our calculator, right? Number of periods, the yield to maturity, the par value, and then what those coupon payments are. And so we can do this for our 20-year and then for our 10-year bond. And that is all of those. So thank you.